Okay guys, I'm just going to take a quick moment to prove an angle thing I mentioned in the last video. So my goal right now isn't to draw a full free body diagram, just to prove something. When we drew in directly down the weight vector, f sub g, we noted that it has two components now. A perpendicular one and a parallel one that we solve formulas for. Get the symbols right here, sorry. The perpendicular one and the parallel one that we built formulas for. And those formulas were built off the fact that I told you that this angle of inclination is always the same angle in this component diagram drawn head to tail right here. But again, in the last video I told you just take my word for that. I'm going to prove it to you right now. Alright? The first thing I'm going to do to prove it is pretend we don't know that for a moment. So I'm going to call this angle Z. Alright? That's the one that I told you that should be the same as theta. Alright? I'm also going to call this angle X. And I'm going to do some messy stuff to this diagram. This parallel component of weight, I'm going to just extend it as a whole line. I'm going to go over top of it. Alright? And I'm going to extend the weight vector as a line that extends forever. So what we have, you might remember from basic geometry, something called two parallel lines with a transversal. Okay? And in a circumstance like that, due to some angle theorems, if this is angle X, so would this angle right here be. That occurs right here. And due to opposite angles theorem, if this is angle X, this is angle X. And if this is truly drawn head to tail in this triangle I made, perpendicular and parallel components, that would be 90 degrees. So I could say, write a formula for this triangle because all triangles add up to 180 degrees. I could say angle X plus angle Z plus 90 degrees, again I'm getting all that from this triangle right here, is equal to 180 degrees. Alright, now we're going to focus on another triangle, the one that has theta in it. Alright, this triangle I'm going to highlight in yellow right here, from here to here to here. Right. This would also be 90 degrees because that weight vector dropped directly down and this line is right along that weight vector to make this triangle. And this triangle also has X in here, which we eventually proved is also the X in that triangle. So we could say that theta, let me use a different color here. We could say that theta, this is from the yellow triangle, plus angle X plus 90 equals 180. Alright, what I really have is a systems of equation here, and I'm going to solve this equation on the left for X. I'm going to give by itself. If I subtract over 90 and subtract over theta, I'll have it solved for X. So if I do that, subtracting over 90 will give me 90 on the other side, 180 minus 90, and then I'll also subtract over theta. Now if this equals X, I could do a substitution, algebra substitution right there. So I'm going to plug in 90 minus theta for X plus Z plus 90 equals 180. Now I'm just going to do some reducing. There's no really need for the parentheses anymore since there's nothing in front of them. So if I could drop the parentheses, I'll have a 90 plus a 90 here. So I'll get negative theta plus 180 plus Z equals 180. I just combined like terms there. And finally, I'm going to solve for Z, because my goal was to prove that angle Z is always equal to theta. So if I add theta to the other side and subtract 180, I'll get 180 minus 180, which cancels, plus theta. And if those cancel, I just proved that angle Z always equals theta. Alright, there's some alternative ways of proving it, but I think that's one way using geometry and algebra we could all easily understand. Never will you have to prove that to me, but I don't want to just say take my word for this without showing you that it's always true.